Hey everybody, welcome back to another chemistry video lesson. Today we're going to look at what's called empirical and molecular formulas. We've looked at chemical formulas in the past, but in this section what we're going to do is we're going to look at where those chemical formulas came from. Like, how do scientists know that the water molecule is two hydrogens and a single oxygen? Where did they get that information, and how do they take data from the lab and interpret it and turn it into chemical formulas? So that's pretty much what we're going to look at. And there's two different types of formulas we'll be looking at, what are called empirical and molecular forms. Okay, so before we do that though, before we get into the two different types, let's take a look at what a chemical formula actually tells us about the substance. Okay, so I think that might be a good place to start. So if we take a look at just one single molecule of water, we probably already know this, but let's just recap here real quick. Every time we have one molecule of water, we're always going to have two atoms of hydrogen in there linked together with one oxygen atom. So for every two hydrogens, we get one oxygen atom, and that's how the ratio works out in the formula itself. Now, as you know, we don't really work with individual atoms and molecules at any given time. We actually work with them in groups of moles. So as we saw before, if I have a mole of something, that's Avogadro's number of particles, which would be 6.02 times 10 to the 23rd particles. So if I have 1 mole of water molecules, what I really have are 2 moles of hydrogen. Because remember, I could scale that up because the ratio is always going to be the same. Every time I have a water molecule, I get that ratio of 2 to 1. So what chemists are trying to find when they are looking at determining what the chemical formulas are is that they are going to be based on the number of moles or atoms in a ratio in that compound. So for water, it's always a 2 to 1 ratio. It's always 2 hydrogen moles to 1 oxygen mole, or 2 atoms of hydrogen to 1 atom of oxygen. What's nice about chemical formulas is that water is the only substance in the universe that is 2 hydrogens and a single oxygen. That's it. So there's no other substance that'll have that. So that's what makes this a good system, is that if that weren't true, if water had multiple formulas, then it makes things very, very difficult. So it's good that it's like that. All right, so let's take a look at the two different types of formulas. Now, there's one formula we call the molecular formula. The molecular formula is used for molecular compounds. So that's going to be, when we're dealing with molecules, we're going to be talking about the molecular formula. It indicates the actual number of atoms or moles in a particular compound. So if I have a formula like this, which would be H2O2, hydrogen peroxide, it's always 2 hydrogens to 2 oxygens. That is the actual molecular formula. Remember, molecules exist as little groups together. If you're confused on molecules and ionic compounds, I suggest you go back and watch the video on that. For right now, we're going to talk about molecules as being these little groups of substances. Another example would be hydrazine, N2H4. This is a molecular compound of hydrazine, which is 2 nitrogens and 4 hydrogens. That's the actual formula of this particular compound. So when we deal with molecular formula, it tells us the number of atoms in the ratio that they are inside of the molecules. Okay, empirical formulas express the whole number ratio, or the lowest whole number ratio of the atoms. So this is like a simplified version of the molecular formula. We're going to reduce them down into their lowest terms. So if we have empirical formulas, they're always reduced down. So this is going to tie back into ionic compounds. Ionic compounds tend to, they should be always written in their lowest terms possible. So if I have something like calcium with sulfur, it's a 2 to 2 ratio. We would reduce that down to a 1 to 1 ratio. So that would be the empirical formula. There are no molecular formulas for ionic compounds. So they're always going to be written in empirical form. But molecules can actually be written in their empirical formula as well. So things like water, if you see here, the example that I have here is water in both empirical and molecular, is because this is a molecule, but it actually happens to be in its lowest whole number ratio. So molecular compounds or molecular formulas can also be empirical formulas if we're talking about molecules that are in their lowest whole number ratio. But ionic compounds can never be molecular formulas. So we're looking at the empirical formulas and molecular formulas. The differences lie in their ratios. So empirical always reduced down. So if I have a molecular formula, what I could do is I could always convert that to an empirical formula. by just doing a simple reduction. Okay, so that would be the difference between molecular and empirical formulas. So next video lesson, what I'll do is I'm going to talk you through how we actually do the calculations and turn data into an empirical formula.